It's important to feed farm animals precisely because by reducing the differences between the quality of the nutrient supplied and the requirement of the pigs or the poultry, we can reduce the environmental impact of production, also reduce the feed cost. To implement precision feeding in practice, we need some information on pigs or poultry on their environment. For pigs and poultry, we need their performance, that is to say their feed intake and their growth evolution. We need also some information possibly on their health status or on their behavior. We need also information on the feed that we want to distribute and also on the environment of the pigs, that is to say the humidity, the temperature, the ventilation rate, for instance. Concretely, the precision feeding system can be described as the following. We have different components. We have the central component, that is the controlling modules that manage the relationship between the decision support tools and the devices. The controlling module receives the data from the different devices, weighting scale, feeder or environmental devices. These data are operated by through the data management system by the decision support system to calculate the adequate nutrient supply to distribute to the animals. And once this information is obtained, it comes back to the controlling module that send it to the different devices that will apply this decision. There is also a possibility to remote access for the user, the end user, that will control the different phases and implement also the different feeding strategies that they want to apply to the animals. The decision support system is designed with different sub-modules. The first module is a communication sub-module to exchange with the controlling module, so receiving the information and the decision. And there is a data management system also that will help to exchange the data in a proper structure with the database that will be integrated in the final tool. Once the information are received, so the input data on animal or on their environment, they are processed first by a data checking module that will help to clean and to fulfill some missing data. The data received can originated also from the end user that can implement their own piloting rules, that is to say targeting body weight or the feeding strategy, that is to say the number of diets that they want to use or the body weight at the change of the diet if they want to implement some specific strategies. So once the data are checked, they are used for the real-time growing and feed intake prediction. That is to say, we want to know what are the most probable performance of the pigs to help to calculate the requirements. One of the main constraints for our research to be applied in farms is to prove the efficiency of the techniques in terms of reduction of feed costs and the improvement of performance, at least in terms of nutrients excretion. And we have also to prove that there is a possibility of good return on investment for these techniques. For the moment, we have already achieved the development of the first prototype of the DSS. We are now in the phase of testing the DSS in practical condition in the experimental farm of IFIP and INRA. We are optimistic about the success of this development because we have already programmed, implemented informatically the tool, and we are currently testing it, and we are managing to deal with the different data dynamically and to distribute a feed in the good proportion of nutrient. Finally, our tool will be integrating in the final prototype. This prototype is built using the controlling module developed by the University of Lerida and by the device prototype feeder device that is developed by the Hexafan company. So our tool will be integrating in the general prototype and will be tested in the next year.